zip code. So you can see the WSL here, and you can see check here. You can Ubuntu and click on this. You will open in the browser in the terminal. You will open here, and you can see that my screen. This is my Ubuntu, and if you want to go to disk, right, you will see there is a folder. If you go here Linux, right? If you go here Linux, you will see here the Ubuntu 24.04, and this is the same like your Ubuntu disk folder. Okay. So whenever you want to copy anything, like you will be, suppose I'm installing the softwares, right? So you will see everything here. Whatever your home directory, this is my home directory, and this home directory, my user directory, and that directory has the software directory. So I have installed so far only Hadoop. Okay, so you can see my Hadoop 3.3.6 folder, right? So if you look at here, if I check this path, right, if I can check my path, I can go to cd/softwares and then Hadoop. So I can see the same directory, right? So this is my Hadoop directory. So when next I will be installing the Hive, I will install Hive itself also in the softwares. Okay, I will download the zip and then extract the zip, and then I will set the bash RC path. So any like your home path or bin path you are setting in the bash RC. So always open your bash RC in your home directory. So you are able to see here PWD. You can see here the PWD. This is my user home directory, and here you will open nano bashrc. So you will see here in the nano bash RC. So in this nano bash RC, you can see I have set the Hadoop home and bin path. Okay. So whenever you are installing anything in your Ubuntu, you will be setting your path here. Okay. And you want to save this file. What is the option? Control X. Because I have not done any change, so it is not asking me to save. Okay. Suppose if I do any change, if I just enter one line here, I'm just going to show you. Just I'm entering one line. Now my changes are there. Now I will do Control X, Shift Y. It is asking me whether you want to save it or not. So if I say Shift Y, it will save. If Shift N, it will not save. When I say Shift Y, and then when I do the Shift Y, and then I press Enter. So when I press Enter, my changes are saved. But these changes will not be reflected till, okay, when you don't do your source command. You already know about this. So when you saw in installation, you have to always do the source command. So whenever you are changing even a single line, anything, any word, right? So you have to apply changes by using the source command. Okay. Source -rc, right? So this command you have to run. Okay. Now let's start my Hadoop. My Hadoop is already there. I'm going to check. I'm showing you the softwares like what I installed and how to check that. So if I check my Hadoop is running or not. So if I check the JPS, if I check JPS, so I'm checking there is no service running, right? There is no service running. If I'm trying to check my Hadoop command, Hadoop fs -ls/, so you will see it is saying connection refused. So it means my Hadoop service are not started yet. So in Ubuntu, every time you have to start the service manually. So whenever you log in your Ubuntu, then you have to start your service manually. So how to start the service? So you can do start-all.sh. Okay. So it will start your all Hadoop services. Total 5 services are there. Name node, data node, secondary name node, and resource manager and node manager. Okay. So these 5 services will be starting. Okay. And once these services are started, then I will check the JPS. Okay. I will check the JPS command. So you can see what is the difference. Like it is so faster, right? Because we are not using any virtual box. Okay. So now I'm going to check my JPS command. Now you can see total 5 services are coming, right? Now, if I check Hadoop fs -ls/, okay. So this is the root directory. So I have already created one test directory in the root, right? In the root directory. And whenever you are using a Hadoop, when you're using a Hadoop, you should always use a complete path. You have to give a complete path of your directory. Okay, I will show the command. Okay, just I'm going to show like how to check your Hadoop. Okay, So right now my Hadoop is running fine. My Hadoop services are running fine. Okay. So everyone has the Hadoop installed. Okay. And the next thing I will install Hive. Okay. I will show that I have not installed Hive yet, but I will show you Hive also. Okay. Okay. Let's start. Like what is the agenda? Okay. So this is the first session. I'm going to start from the very scratch. Okay. So Linux things I will cover in the weekdays. Okay. So I'm not starting the Linux today. Okay. So I'm starting from the very first thing is a big data fundamentals. Okay. So first thing is what is the use of this course, right? What is the purpose of this course? Why I'm learning this course? What is the purpose of this course? And what is the benefit of this course? I have to learn and I have to use it. Okay. So first thing is when I'm saying, okay, I want to learn big data, right? So big data is basically you are working on the data is a huge amount of data and you are doing the big data analytics. Okay. Have you heard about data analyst role? So data analyst role is also similar to big data analytics. So what is the difference between the big data analytics or data analyst? See, data analyst is not related to data engineering. Big data analytics is related to data engineering, right? So data engineering is superset of data analyst. Okay. So you can say data engineering is a vast, okay, and data scientist that comes on top of the data analytics, big data analytics. So there are the different roles are there. The top role is data scientist. Okay. If anyone has any question, doubt, you can ask unmute. And if you are not asking any questions, so please not unmute. Okay. So data scientist is the on top of the bigger role. Okay. And some people they can directly become data scientists if they have very good learning knowledge in statics, okay, Python, okay, SQL, right? All these are, I can say, machine learning. Okay. So some people they have a very good hands-on knowledge on this. They can directly become data scientists. Okay. And the second way of becoming data scientist is either you are a data engineer or you are a data analyst, right? So they are the two other ways to become a data scientist. Okay. The next thing is big data analytics. So that is a data engineering field. And data engineering field is not only data engineering, there is a combination is cloud plus DevOps. Okay. So this entire field is called big data and you can say cloud DevOps. So cloud DevOps is a combination of three things: cloud plus DevOps plus data engineering. Okay. So if you have this combination, so this combination will be a unique combination which is covering the cloud services, and cloud may be a different clouds are there. You can go as a Azure data engineering. So there are the different branches are there. So three total are there: Azure data engineering. Another one is a GCP data engineering and AWS data engineering. So these are the top three data engineering job profile. Okay. And these three have the same data engineering and DevOps, both are there. Okay. When you are working in the Azure data engineering, you will be using Azure DevOps, like Azure CI/CD pipeline. So you will be using Azure DevOps. And when you are in the GCP data engineering, you will be using GCP DevOps. Okay. The GCP services are there for the DevOps. So GCP DevOps is there. So GCP DevOps like GKE is there, Google Kubernetes Engine. Okay. And when you are in the Azure, there is a AKS is there, Terraform is there. So those things you will be using. So Terraform is completely common. So Terraform is common across all the data engineering, right? Whether you are in Azure data engineering or GCP and AWS, okay? But when you are in AWS data engineering, you will be using AWS DevOps. So there are the AWS DevOps services are there. But some services of DevOps are common to across the cloud. So Git is common, Jenkins is common, Docker is common, and Kubernetes is common. But Docker and Kubernetes, the managed services are provided by these cloud. AWS is providing EKS. Okay, AWS is providing EKS, Elastic Kubernetes Service. Azure is providing AKS, and GCP is providing GKE. Okay, so these are the Kubernetes managed services, right? But if I say bare metal, if I say QADM type, okay, QADM, so that is a bare metal. Okay, so that is common to across the cloud. Okay, and this is the DevOps things. Okay, and cloud is the cloud services. Specific to the cloud services are there. If I'm talking about the AWS, the basic services of the cloud, like EC2 instance is there, S3 is there, RDS is there, DynamoDB is there as a NoSQL database. Okay, you can see the complete chart of the services where you can find this service is present in this particular cloud and this particular service is for this particular purpose in this particular cloud. Okay, so DynamoDB is there, and there are some services. AWS data engineering services are there. So AWS data engineering services, Glue is there, that is a Spark. Okay, that is a Spark, and EMR is there, Elastic MapReduce. Okay, and Kinesis is there. Okay, so these are particular to data engineering, but there are some more services are there. Lambda is there, and Event Braze is there. Okay, so and some supporting services are there. SNS is there, SQS is there, right? SCS is there, right? So these are the some other additional services are there, right? So plenty of services are there, but I will say when we are learning the AWS data engineering, so we need to have knowledge of all these cloud services. Okay, when I go to the Azure data engineering, so Azure data engineering is using Azure VM is there. So that is like a same like a EC2 Azure VM, and there is a blob storage is there, storage account. Okay, we call it Gen 1, Gen 2. Okay, so Gen 1 and Gen 2, there are the, and other one is like Azure data engineering. So Azure data engineering services, ADF is there, that is a ETL pipeline, and ADB is there, Azure Databricks, and Databricks is here also because Databricks is common across the cloud. Okay, so there is a different Databricks, like AWS is having AWS Databricks. Okay, Azure is having Azure Databricks. This is the Azure Databricks. Okay, and Snaps is the one more service that is also analytics service. And apart from that, some streaming services there, that is a Event Hub. Okay, Azure Event Hub. Okay, so I'm saying like if one cloud you understand very well, you don't need to go every cloud at the same time, but you can at least two cloud you can prepare very well. Okay, when we come to the GCP data engineering, so GCP has its own service, like GCP is having the VM. Okay, GCP has like GCP GCS, the Google Cloud Storage Bucket, GCS bucket, and we have other services like Dataproc. So GCP data engineering, we have Dataproc cluster, that is Hadoop Spark cluster, Hadoop and Spark cluster, same like a EMR, Hadoop Spark cluster. Okay, the same thing is here in the Azure is HD Insight. Okay, this is in Hadoop Spark cluster. So you need to understand these all differences of the services. What is there? What is purpose of the each service in each different cloud Hadoop Spark cluster? Okay, so first you concentrate what cloud you want to go. You decide your own cloud, right? Which cloud you want to, like first priority you can keep it AWS, and second you can keep it one more out of these two. Okay, or if you want to go Azure data engineering, so keep it first priority Azure, and other one you can pick from other two. Okay, so that a good combination you can take it up. Okay, so at least one project you keep it one cloud, and one project from your before the current project you can take it another cloud. Okay, so that way you can show your experience in multi-cloud. Okay, because the companies is looking for the multi-cloud experience, because sometimes they are using two cloud at a time in the same project, right? For two different use cases. Okay, so when I'm talking about the GCP data engineering, so Dataproc is there, PubSub is there. PubSub is like a same like SQS in AWS, and it's a message broker service, message broker. And apart from that, there is a BigQuery is there. If someone heard about it, BigQuery, Bigtable, right? So Bigtable is a NoSQL database. BigQuery is a data warehouse tool. Actually, here I forgot to AWS is Redshift. Okay, so this all complete list is there. Okay, and it is endless. As many as services you want to do, you can do. Okay, but perfection will not come in all the services at the same time. So you need to learn some of the services very well, and other services you have to understand, and then you can do some practical hands-on. So BigQuery, Bigtable, and Composer. This is very important one. Composer is Airflow. Okay. So Airflow is a scheduler service. Okay. In Composer. And apart from that, some one or two services also, some CI/CD pipeline services are there. Like when you talk about the GCP DevOps, so there is a GKE is there, and then some SQL databases also there. Okay, so some Cloud SQL is databases, SQL databases services there, SQL databases. Okay, so all the clouds having same kind of services, same purpose of the services are there, but they have different names. Okay, and but they are using the same purpose. Okay, when we come to the data analyst, so data analyst is Python, SQL, Tableau. Okay, it's a position of the Python, SQL, data, and Tableau, right? So basically, the data analyst role is like if you prepare Python, SQL, so that you can go for data analyst role as well, right? If you cover Python, SQL, Tableau. Okay, so Tableau is covered here also because we have to learn BI tools as well. Because when you are learning data engineering, so BI tool is also a part of data engineering, right? So BI tool we cover like Tableau integration and Power BI. These are the two powerful Power BI. Okay. So Power BI is a Microsoft based, right? We can use Power BI desktop, right? Power BI desktop we can do. Okay. So some small like dashboard we can prepare from our data, and from different sources of the data we can ready our Power BI dashboard or Tableau dashboard we can do. Okay. But we don't need a very in-depth knowledge, because Tableau and Power BI is a separate role is there, a profile is there, right? BI tool profile, and we don't need to go for that profile. Okay. So our purpose is to do hands-on on our data engineering, where our main target is cloud DevOps and data engineering. Okay. Anyone has any questions so far to understand what is a data engineering role? Okay.
No questions.
Okay, fine.
So for the data engineering, any language like Python, Java mandatory, or we can do all with Python?
Yeah, that's a good question. Say sometimes people are asking big data with Java J2E. Okay, when they call it Java, so they are looking for some Java project. Is the uh, project is in Java, like a Spring Boot project. Okay, so they want the expertise in the core Java and Spring Boot and REST services, right? So there is a Java is mandatory, because without Java they will not hire as a big data guy. Okay, but additionally they are looking for the big data experience. Okay, so here they have the choice, either they can use Spark with the Java, or they can use a Spark with any other two choice, Python or Scala. Okay, so the chances are more is the Spark Java if they are using big data with Java project, Spring Boot project, because the Java compatibility will be more is there in the Spark Java integration. Okay, combination. Okay, but some project, this is the one type of requirement, they are looking more experience in the Java, and so there is Python is not mandatory. Okay, or even Scala is not mandatory. Okay, but sometimes the requirement comes, right? There is no role of the Java, they are looking PySpark or Spark Scala. Okay, so in this case, so Python is always mandatory. Why? Because even you are not using Python in Spark, but you are using Python as a core programming. You are using Python as a core programming, like for writing the scripts. So you are writing a validation script. You are writing. Sometimes you are writing some programs, like your utilities. You are developing some utilities. So for that purpose, the Python is mandatory, right? So even you are using Python in your Spark or not, but Python is always required. But Scala is a choice. Scala is a choice because Scala is a combination with Spark only. There is no use of Scala at all without Spark. Okay. So if you are using Spark with Scala, then only you need a Scala. Otherwise, Scala will not be needed. So I talked about Java is needed, when the project is needed a Java knowledge, then the Java is mandatory. Otherwise, Java is not required. But some knowledge of Java is needed because when we're learning the Hadoop ecosystem component, so we will use a Hive UDF, right? So Hive UDF we will write in the Java. So there are the two ways we can write, either Java or Python. Okay. So if we have that little bit knowledge of the class, see, OOPS concept, what is in every programming language? If I say Java, Python, or Scala, so what is the common in these three programming languages? I say OOPS is common, right? Everybody agrees on this. Functional programming is common. Lambda, right? Functional programming. Everybody knows that Lambda is everywhere. In the Java, Lambda is there. This is not Lambda of AWS. I'm talking about Lambda expression. Okay. So functional programming is a Lambda. So Lambda is an anonymous function, which is providing a lesser code to write to avoid the lengthy code. Okay. So Lambda is the, like in the Java, when I say, so Lambda is this symbol. This symbol is a lambda. Okay. When I talk about the Scala, the symbol is, okay, sorry, this is a symbol. And I say Python, we write a lambda is a keyword. Python is a lambda keyword. Okay. So functional programming is there. OOPS is there. Okay. So these are the two core concepts, right? Like OOPS, we come with the programming concept is like inheritance is there. Polymorphism is there. Polymorphism, class concept, polymorphism, class concepts are there. Okay, class objects. Okay, and abstraction is there. So these are the OOPS concept, right? Real time world objects is called OOPS concept. So OOPS, like programming is there in every programming language. Functional programming is there. So you have to learn the concept in every programming language, but the way of implementation is different. When you are writing a Scala code, or you are writing a Java code, or you are writing a Python code, you have to write a different syntax, that different. So if I talk about the next thing in the every programming language, the operators are there, right? Functions are there, like, okay, loops are there, okay, collections is there, exception handling is there, file handling is there, right? So these are common things, right? Common thing means like these are the basic building blocks. So when you are learning a programming, you need to understand what is the data types, what is the operators, okay? So what are the data types are there in every programming language, okay? So Java and Scala are almost matching because Scala is running on the Java compiler, Java runtime environment, JVM, okay? So Java and Scala both are matching almost, right? Okay. But Python is a little different. Okay. So if I say the learning of one programming language, so always like Java, you learn only when you need for any Java big data project. Otherwise, Scala or Python, you can any one of them, these you can learn anyone. Okay. So you start first Python. I believe that if you learn Python, then you can do any language. It's nothing, because when you are attending the interviews, you will get Python and SQL coding. So Python and SQL coding is a mandatory. Every interviews is the Python SQL coding is mandatory. Okay. So you have to write a code either in both, right? They will ask two questions Python or one question SQL, or maybe any combination they can ask. So when they are asking Python questions, so sometimes they ask PySpark. So same program they will ask you to write in PySpark. Okay. Like suppose you are writing some Python code and they will ask you to read a CSV file and do some analytics and write a PySpark code. So this combinations and SQL they can ask, right? SQL join they can ask, some group by. So they will give the SQL queries. You know, there are a lot of SQL queries, so you can practice. Okay. So Python or SQL, that you always keep practice. Okay. But when you are learning PySpark, then you have to learn the Spark API. Okay. Any other question?
Uh, uh, According to this, first we need to concentrate on the Python and at the same time SQL, and then we can go for the big data analytics. Am I right, sir?
Yeah, see, Python SQL you will always be using, right? You will be learning because the very first step of any interview is Python SQL. That is the first door. Okay. When you enter inside this, then only you can go to the next step. Okay. So Python SQL, you always keep practice like 2 questions Python every day, 2 SQL, lead code, right? And Python coding. Okay. And start from very basic Python questions. Like yesterday, one interview, there was word count is there. Very, very easy program. Like they're giving this text file, and this text file, I want to find each word is how many count is there. Like Scala is coming like 1, 2, 3, 4, 5, 6 times. So I want to know the output. My output should look like this. Scala 6 times. Okay. Spark is 2 times. Like this, I want my answer. So you need to understand, if I want to read a file, either in Python or Spark, right? So after reading a file, how can I separate these words? Because these are the lines, right? These are the sentence, right? So first I need to split with the space. Wherever the space is coming, I have to split and take it all word in a single array. The same principle is there in the MapReduce. Like we will take all the word in a one single array, and we will do each word is a 1 1 count. And when we will give each word is a 1 1 count, then I will do the aggregation. What is aggregation? The same word 1 1 count is 6 times. When I aggregate it, it will become total value 6. Okay. So that I will tell about in the MapReduce. There is a map and reduce, 2 functions are there. But somebody is asking Python or Scala, Python or write a code in the PySpark. So you have to use Python code. You have to read a file first. So file handling will come in picture. So this will come first. Okay. How to read a file. Okay. So you have to read a file in the read mode, right? Once you read a file, then you will start splitting the line by line. You will read the file, and then you will split the line with the words in the array, and then you will start the count. Okay. That's easy program. I am saying first need to understand what type of program you should do. Sometimes they are asking a program Fibonacci series. Very, very easy. 1, 1, 2, 3, 5, 8. Can you see what is the combination is coming? How it's coming? 13. Then 21. What is coming? Can anyone tell what is this coming? How this sequence is coming?
Adding before
2
value.
number. So I'm taking a first, initially I will give you these 2 number. I will say 1 1 is given to you input, and then you will start your Fibonacci series. So suppose they are asking you print 10 Fibonacci series values. Okay, so what you will do, you will take 2 numbers and add. Then next 2 item you will take and add like this, and then you are doing swapping. So here is a three step is there. First you are making C equal to A plus B. Okay, and whatever is your A, you will make it B, and B C equal to, like you will be doing swapping, right? So once your C, you will print the C. Okay, whatever sum come after that, like A value you will be assigning B, and B equal to C. So can you see here? Like next time when the loop it will run, automatically it will take these 2 values. Next time it will take these 2. That, and then you will be printing. Okay. So this kind of Fibonacci series, sometimes they ask palindrome number, palindrome string. Okay. So these kind of programs, reverse string. Okay. So very simple programs are there. Okay. Like if I say this hello string is there, I want to write in the Python. So I can use slicing. Suppose this is my string str. This is my string str hello. Okay. And I want to reverse it. So in the Python, it's anyone know, right? This slicing. What is slicing? Str double bracket, you can use colon -1. If you do this, it will reverse, right? Okay. So you can simply do the slicing and you can do the reverse. Other way is you can iterate for I in str, and then this is, but you have to do the length, right? You have to find the length. Okay. Or you can find the length here. Length, you can check it. Okay, and then reverse the loop, right? And then you will know here you have to take the each character, but you have to range, you have to use, and then you have to tell the length of str you have to run, and the reverse character you have to print. Or you can do one thing, you can add in the list and then reverse that list. Okay, so there are multiple ways are there. Okay, So programming is like a practice thing, because programming you cannot take it right in a one day, right? Programming is more practice, right? Okay. Okay, so this is like a ongoing thing, because our concentration is not to learn Python SQL. Okay, our concentration is this entire technology, because ultimately you will be working on this technology, right? You will be using Python, but Python is a base, right? Python is a base, but ultimately you will be using this Hadoop things, Spark, Kafka, all these things you will be using. So when we start in the data engineering, the first four sections, like first I'm saying, okay, Hadoop is there. Okay. So Hadoop I'm using nowadays, like very less people are using Hadoop, but still Hadoop is not gone from the market yet. Even the cloud is providing the Hadoop. Okay. So Hadoop and Spark is providing the cluster, right? EMR cluster, and Azure is having cluster, Dataproc cluster in GCP, right? So Hadoop is there, right? So Hadoop cannot go, because Hadoop is providing a large data analytics, right? Very, very large amount of data. You can do analytics, right? Okay. So I will talk about what is the Hadoop services are there. So Hadoop is having the first component is HDFS and then MapReduce. These are the two core component of Hadoop, one for storage and one for computing. Okay. So HDFS is used for storage and MapReduce is used for computation, right? So when I talk about these two components, but MapReduce nobody using nowadays, because Spark is has replaced the MapReduce. So we will learn just MapReduce fundamentals, like basic concept of MapReduce, what is a map function, what is a reduce function, and what is a MapReduce is having the partitioner and combiner. I will not be showing a coding in this. This is completely Java. Actually, first of all, this MapReduce is a Java. Okay. So I will be just showing the example so that you will get an idea what MapReduce program looks like, and just understand the MapReduce fundamental. Okay. Next component comes in Hadoop, that is Hive, right? So Hadoop ecosystem, this all component of Hadoop ecosystem. Hadoop ecosystem is a combination of the different set of tools for different purpose, right? Like Hadoop distributed file system is for storage, MapReduce for computation, and Hive is for the SQL data warehouse tool. Same like a Redshift and the other one. So SQL data warehouse tool. So it is completely Hadoop based tool. So whatever Hadoop ecosystem component I am talking about, these all install Hadoop first. Otherwise, you can't use it, because Hive is having the dependency on Hadoop. Okay. So Hadoop installation you need first, then you can go the next installation of Hive. You can go the next installation like Scoop, and Scoop is a ingestion tool, and it's a data import export tool. Okay. So it is import and export tool of data from RDMS. So RDBMS database, you can import the data into Hadoop file system. Okay. So we cannot generate the huge amount of data in Hadoop file system. We cannot write our own, right? We have to bring the data from external system. Another tool is Flume. Flume is ingestion tool again, but this tool is for unstructured data. Okay. This is for unstructured and semi-structured data. So unstructured data and semi-structured data. So unstructured data is the like audio, video, images, and semi-structured data is like XML, CSV, JSON file data. Okay. Or some data is coming from the Twitter, like streaming data, Twitter hashtag data. So this hashtag data, you can get it using the Flume in your Hadoop file system. So when you import this data from different source, right, and then you bring the data in Hadoop file system, then that is done by the Flume. So Flume is another tool. So 1, 2, 3, 4, and Flume is 5. Okay. So these are the tool, and one is last is NoSQL database, that is HBase. Okay. So HBase is also used in the as a NoSQL database. That is a part of Hadoop ecosystem. So total 6 tools are there in Hadoop ecosystem. And next, when we go to the second module, that is the Spark. Okay. So Spark, when we learning Spark, so we need a Spark core fundamentals. So Spark has the modules. So Spark has the module. So Spark core is a base module. okay, which is basically covering the transformations and actions. Okay, so Spark is an analytics tool. It is not a storage. It is same like a MapReduce is doing computation. The same thing is Spark is doing. But the advantage with the Spark is it is 100 times faster. 100 times faster in memory. 100 times faster in memory as compared to MapReduce. Okay, and 10 times faster in the disk. 10 times faster in the disk. Okay, so that is the reason why the people are going to use Spark, because Hadoop is basically Hadoop MapReduce is the batch processing only. It's a batch processing. So MapReduce is the batch processing. Batch, only batch. Okay, but Spark is batch and real-time both. Sorry, I have written here. This is only batch processing. So MapReduce is the batch processing only, but the Spark is batch and real-time both. Batch and real-time both. But the main use of the Spark is the real-time processing, because historical data processing, like batch processing, is a historical data processing. Like I have a data of 10 years data, 15 years data. So that type of data processing I'm going to use. I'm using a MapReduce or Hive I can use. Okay, historical data processing. Okay, but when I talk about the real-time data, the data is coming on the fly. The data is coming, streaming data is coming, like Twitter data is coming, or some data is coming from the Kafka or some real-time source. So that data, or REST APIs. If I'm getting a data from the REST APIs, or I'm getting a data from Kafka or Twitter, right? Or I'm saying some banking application is there, right? So they have the credit card swiping is there. So these are all real-time data, right? So real-time data processing, we go for Spark. So Spark core is providing the transformation action. And another module is there in Spark is a SQL. So Spark SQL module is basically meant for data sources, like batch processing data sources, Okay, in Spark, I told you, right, two are there. So Spark core is a base which is providing transformation action, but Spark SQL is for batch processing data sources, like files could be there. It could be a SQL databases. Okay, so SQL databases you can read the data, or no SQL databases you can read the data, but not the real time. But when you say Spark streaming, the Spark streaming module is basically meant for real-time data processing, So the Spark core is common for both. Your Spark core is common for both. It is common for your SQL and it's common for streaming. Okay, Spark core is common. Okay, so Spark core knowledge is mandatory, but SQL or streaming is depend on your choice of your application you will be using. If your application is allowing you to read a files data or SQL database or no SQL database, you will not use Spark streaming. But if your application is saying it's a real-time data processing, like same like REST API, Twitter, Kafka, or banking application, then you will use the Kafka on Spark integration streaming, Spark streaming. Okay. So this is the 3 modules we are doing. Total 5 are there, but those 2 other like we don't focus, because those are one for Spark ML machine learning libraries. So those are for the data scientist people. Okay, so data scientist people and machine learning who's using in the project as a machine learning. So they use Spark ML. So Spark ML is on top of the Python. So somebody can use without Spark, machine learning can use, but that machine learning is not giving the benefit of Spark. But they are using Spark ML, they will get the Spark benefit. The Spark advantage is the faster computation, right? Your Spark job will be faster. So that then they will be using the Spark ML libraries. Okay. So this is Spark ML lives, right? Providing the methods for machine learning. Okay, so this is we are not going, because mostly projects are like data engineering projects, they have very rare chance they have the machine learning. But if machine learning is there, so they have a separate data scientist guy. They will not expect you should be working on the machine learning algorithms, because you are hired as a data engineer. So your mostly work in the day-to-day work will be data ingestion. You will be ingesting data, and the second one is the data analytic work is yours, like high level data analytics pipeline, ETL pipeline you will be writing. You will be writing data ingestion and data analytics, and other things you can do the data integration with the BI. That is your role, data integration with the BI tool. And here also you are just providing your data. You are not like improving the dashboard. You will not be improving the dashboard, or you will not be using in depth of BI tool. Okay. So your job is to here provide the data some BI guy. So here is a separate BI guy is hired, and data scientist is separately hired. Only your part is to communicate to both of them. Okay. So a data engineer guy is interacting with different people, right? Data engineering guy is interacting with the DBA guy. Okay, database administrator, he is interacting is a big data admin guy. Big data admin, like some installation related or some access permission issues, because sometimes we join company, so we need a access of cluster, and we need a access of specific tools, right? Permissions we need. Okay, or server folders, right? Some specific server, right? You have access of a folder, you will request to the admin. So you will be requesting permissions, right, for servers, folders, okay, or tool access, anything it could be. And another interaction, you will be interacting with the architect. So architect is the main interaction, because you will get more information about the architecture, about your task and story. You will get more information from the architect as a architecture point of view. Okay, because there are the two things are there before starting your task. One is functional flow and technical flow, right? Technical design. So for functional design, for functional flow or design, you have to interact with the BA, business analyst. Business analyst is a guy who is providing you the business information about your story, right? Okay, what is the incoming data? What is the outgoing data? What type of transformation you have to do? So input data, okay, input data information, and what type of data it is, type of data, okay, and transformations, like you are going to use a transformation like join, aggregations, looping, functions like filter, map, so those type of transformations. And business analyst guy is helping you to understand what is the target data store. Okay, so end-to-end business flow, and that will be taught by you, right, from the BA, and you will be prepare your documentation. Okay, just for your understanding and for your clarity, like you can clear your doubts and questions from the BA. Another technical design things, you will interact with architect, because architect will be like who is a data architect, and he will be telling you what type of alternate things you have to use. Suppose you are going to read a JSON file, so either you should use the like you are reading a data in the Spark, right? So what APIs methods you have to use. So all those things, like you have to prepare your technical document and get it approved from the architect. Generally, this is the way like you can start your work. Okay, because blindly you cannot follow the technical design, architecture design, right? So you have to interact with the BA architect. But some projects there is no architect guy is there. Generally the lead guy, the team lead guy, okay, like, or you can say sometimes technical manager guy. Okay, these are the playing a role of architect. Okay, so in my team there is no separate architect is there. My team lead is my, he's telling me the architecture, or like your technical manager. Okay, so technical manager guy can be architect. So who can be, it's not a matter. So but you have to know the technical design and functional design. This is important to start any work. Okay, without that, if you start, then you may have to rework, right? Maybe like your understanding is different from the business point of view, functional point of view, or technical point of view. Okay, okay, so these are the like module I was talking about in the Spark. So Spark has the other integrations also. So Spark integrations. So this is like this one, what we are talking about here, the SQL and NoSQL. So here NoSQL databases, we cover Mongo. We have to learn Mongo, right? Because nowadays some projects is using MongoDB, okay? Or Cassandra. Cassandra is also one NoSQL database. So Mongo and Cassandra, and Elasticsearch also. Okay, so these all Elasticsearch also. Okay. And if I talk about some other integrations like Snowflake integrations, okay, or I can integrate with the Airflow or NiFi. Okay. So everything can be integrated with Spark nowadays. Okay. So these all things we need to learn in the Spark integrations. Okay. Then our Spark will complete. So the most important thing in the Spark is transformations things, right? How you can understand well about these transformations, like transformations and actions. Okay. Because the analytics part you are doing in Spark, right? Spark, so before doing any analytics, you need to ingest the data. You have to read the data. So that ETL, right? So you have data ingestion is a part of Spark, but the main use of the Spark is data analytics. Like, okay, you are writing the transformations, right? Okay. It's clear, this one, the Spark part. Okay. So next is a cloud module. Okay. So we already discussed about, right? The cloud is depending on the cloud choice. Okay. So AWS cloud, Azure cloud, and GCP cloud. So these three are the big cloud. I'm not saying all cloud you should do. If you want to do only one cloud, so just focus on AWS. If you want to go for Azure data engineering, focus on Azure. Or if you want to go GCP data engineering, you can do. But at least two cloud, if you keep it in resume, you will get more calls, right? At least you can consume more calls and then you can start attending interviews. So one cloud, you can show your abilities, you can show your expertise, and the other cloud, you can say you have done some POCs. Okay, you are very aware of these terms, right? Other cloud. So nobody is going to ask two different cloud at the same time in depth. Okay, I have seen so many interviews, nobody is asking like that. Okay. So whatever cloud they are using, first priority is that cloud. Okay. If they are using GCP, so they will definitely ask you GCP questions. Okay. But if they have another cloud in their project, then they will ask you the second cloud. Otherwise, they will not ask you the second cloud. Okay. So this is the cloud module. And the fourth is DevOps module. That is our last module. And this DevOps module will cover infrastructure things, because when we are making it ready, our infrastructure, somebody's asking question, what is proof of concept? Okay. So proof of concept is like some application, like before going to the project, right? Before starting to development, sometimes one proof of concept application we need to develop and showcase to our team. Okay. And the team is like that, they can find more understanding, more clear idea picture about the so proof of concept is a small data set you take. You will not take a large data set, just sample data set, and you will develop some pipeline, and then you will showcase to the team, and then team approves it, and then you will start the actual work. Okay. So proof of concept, some projects you can show, right? That you can say you are not working officially in the project. Okay. As officially it was not in project, but as a POC, you have worked on those specific areas which you are not very sure. Okay. So DevOps tools are infrastructure development tool. And why we need to learn the DevOps tool as a data engineer? The reason is nowadays every companies are expecting the knowledge, expertise, or monitoring, troubleshooting knowledge in the DevOps, because without infrastructure, you cannot start your application. Suppose I'm going to say, I want to start my story, right? I have assigned some Jira story, and I need a Hadoop Spark development. I have to do Hadoop Spark. I have to use. How can I start? Without installation of Hadoop Spark, I cannot do. So DevOps role comes in picture. So nowadays, DevOps plus admin both are having similar role, right? Because admin people who are providing you the access, but DevOps people are more concentrate on the application related software they install. Okay. Admin is moreover related to like cluster related, like cluster, right? Your Hadoop Spark cluster, or like your machines, like your VMs, right? Whatever machine, or your edge node, you can say edge node. Okay. So you are accessing your edge node, and these edge nodes are accessible, right, by like admin is doing. But DevOps guy is particularly infrastructure on infra for application tools, right? Application development. Okay. So if I say Git is a mandatory one, because even the developer is using the Git, right? So Git is mandatory. That is a code repository management tool. We use the Git. And the Jenkins, we use automation for the CI/CD pipeline. We want our code automation. Like whenever I check in the code in the repository, my code should be built automatically, deploy. So I will not do the manual step. I will not create a jar manually in my local IDE, and then I will copy the jar manually by using the FileZilla or WinSAP. So these things are not being done in the higher environment. Local environment is fine. So there are the different environments are there, like dev environment, QA environment, UAT. Okay, like we call it pre-prod. We call it, this is pre-prod. Okay, and another environment is prod environment. So that is our cluster environment. Prod is a customer or client environment. So dev environment is for our development environment, development, and this is the developer testing environment, developer testing environment. Okay. So when I go to the QA is specially dedicated for the testing team. So this is a testing team environment. Okay. And when I go to the UAT, this is a client side testing environment. Before going to the production, this is the client side testing environment of the client side testing environment. Okay. And this is the final, like the customer environment. Okay. So end user environment, right? So this one is a live environment, what we call it, like our application is going go live, right? So when we talk about the go live means that is a prod environment. And it is very crucial environment because the access of those things are not given easily without any specific requirement, because this environment is a live environment. Okay. So they cannot do any mistake on that. So they keep it very secure. Okay. So our stages are there. Whenever we start development, so we will test our application in the development. Then we will give the QA team. QA team will be the testing team. They will be testing the application in the QA. And once the application is tested here, then the client side team will be testing in the UAT environment. And once the client side team is approving your fix, right, or your feature or your enhancement or your new development, then that feature or enhancement will go to the production. Okay. So these are the stages. I think everybody knows who are working in any profile, right? Even the Java or programming language or .NET, anywhere, right? So these are the common strategy, right? It's not specific to the data engineering, because data engineering is not this environment things is all common, right, everywhere. Okay. So CI/CD tools and Docker Kubernetes. So Docker Kubernetes is the containers tools. So these two we use for the containerization purpose. Okay. Docker and Kubernetes. So nowadays people are looking for the knowledge of the people, like looking for the Kubernetes, because nowadays everything is going on the containers. So whatever manual installation we are doing, like I have shown to you, like I'm installing this Hadoop manually. So these all things we don't want to install manually. We will be using containers, right? Lightweight, okay, containers. So that is different things, and we will go there. But first we have to start from the scratch, from the initial basic installation. And then once we understand the installation, then once we coming to the DevOps, then we will be learning the Docker Kubernetes containers. Okay, so containers, this Kafka, Airflow, Spark, Elasticsearch, NiFi. So whatever you install manually, Mongo, NiFi, Mongo, DB, Cassandra, okay, everything we can install it by using the containers. Okay, so these are the 4 modules. Okay, is it clear so far? The complete flow, right? What is the what? Yeah, anyone has question?
Roadmap is very clear, sir. One by one, you have said the 4 modules will be covering for this particular data engineering. But according to my analysis, I'm tracking one thing, sir. Here, if any youngsters are just completed BTech, they might be getting confused that what are all these like that? I guess. But you are having very vast knowledge. But they might be getting what are these many.
Yeah, I say this is not a one day thing. Like anyone can learn all these things in one day. People takes years, month, right? Like that. Okay.
Yes, exactly.
But it is up to our capability. I'm not saying one day, but I can say this is not more than 2 months. Okay. If someone is doing dedicatedly, so this is all not, I'm not saying all three cloud. I'm saying one cloud plus all data engineering and DevOps. That could be possible in 2 months. Okay. But with the practical hands-on, not just like theoretically, you just learn like what is Hive, what is Spark, what is Kafka. Now definition things will not work out. Okay. Yeah, yeah, Ganesh. Yeah. Hmm. Hmm.
So as part of the requirements, I'm seeing a lot of performance
Hmm.
thing
Hmm.
because it's between multi-cloud or
Hmm.
different tools. There will be a network latency or some other networking issues. Is it
Hmm.
something you gonna cover as part of this?
See, performance is like, okay, we go to the Spark. So Spark is a performance tuning things people ask, right? How you can improve the performance. See, simple application, you can write it. But after writing application, suppose your data is a huge amount of data or your data is increasing day by day. So the bottleneck is your performance, right? Like how to check the Spark Web UI, how to debug the job, right? How to identify the bottlenecks, right? And what are the issues, data skewness, okay, and data, minimize the data shuffling. So first we need to understand theoretically. See, something you want to start practical, you cannot go blindly and directly start. You have to understand theoretical part and the basic fundamentals of the tuning. Okay, so we will apply our tuning techniques on the data. And I'm not saying that in a one go we can apply and we can get the result. It's like a hit and try. Okay, suppose I'm doing a data skewness issues, I'm just using broadcast join, I'm using a data serialization. So I have a checklist, right? Suppose I'm saying I have a 10 items in my checklist. I will apply one by one and I will keep checking again and again. And wherever I find, okay, I'm getting a better performance and I'll start going deep dive in that. Okay. So this is the strategy I'm saying. I can say like nobody can be perfect in that performance tuning. It's a very complex topic. Even I cannot say I'm 100% on the perfect on that because it depends how much use cases you are getting, right? If I'm not getting that kind of use cases, but generally companies ask about this, and sometimes they have special issues of the performance only because they say, okay, you have to improve the time 3 hours to 30 minutes. How will you do that? So you need to check joins. You need to check what special joins you can use. How can you improve the joins? How can you improve the data, minimum the data shuffling? So performance things is all on the depending on your understanding and more on the theoretical understanding and then do practical. So for that, lot of blocks and points are there. I have collected. I say like it's a like a joint way to learn or work, right? It's not like, okay, I will teach you as a like I can teach performance tuning techniques, but real time I cannot show to you, right? But that type of things we can create. We can try one job and we can try to improve that job, right? But we need to take the large data. Without that, we cannot do that. Okay. So performance things is the bottleneck. Okay, that definitely we have to learn and but that is like first we need to understand what is a Spark first, right? What is a Spark SQL, Spark core, Spark transform. So then we can go for performance tuning. That obviously is not we cannot leave. Yeah, yeah.
Sure.
So everything is needed, right? Without we cannot. But fundamentals is important, right? I cannot go to the XYG, right? I have to start ABC, right? So ABC, then we are going step by step, and I'm saying everyone cannot perfect. I'm saying a real-time experience will come when you will start the project, because this, whatever we will take the data sets or examples will do, these are just learning, right? Not the real-time project, okay? But we can take up some project scenarios, some data sets we can bring, and we can start writing a Spark job and then experience of performance things, right? And for performance, we need to understand the Spark Web UI thoroughly, right? How we can debug. And I see many people have explained very, very well, right? They have really worked on and they have put their experience in their blogs, their YouTube videos. So once you start understanding the fundamentals, then definitely these blogs and videos will be very easy for you. Okay. Okay, so it all depend, right? First, our target is to understand fundamentals, then we can go with this all. Yeah, performance tuning. Yeah. Okay. Anyone else?
So you're gonna go over the Spark architect, right? Later on
Which one? Architecture?
for Spark. Once we get to Spark, you're gonna go over the whole architect, right?
Oh, become architect, you are saying?
Yes, the Spark architect. Are you gonna go over that later on?
Yeah, architect is see, I didn't understand. You are talking about the how to become architect, you are saying, or you are saying like how we can go more on the architecture part?
Uh, uh, I'm saying like, are you gonna go over the Spark architect later on? Once you get to
See,
once you get to that. Okay.
Spark architecture is like we have to understand the architecture only, then only we can, like cluster manager is there, like those are the basic fundamentals, and it comes in the Spark core. So
Okay.
that is a part of Spark core, because when we are learning this transformation action, before that we need to understand the Spark like architecture only, because the Spark architecture will tell us like what is a DAG scheduler, what is a task scheduler, what are the stages, task, right? What is a DAG? What is a data lineage, right? RDD
Yeah.
lineage,
Yeah.
sorry,
Exactly.
RDD
Okay.
lineage, and what is the lazy evaluation? So these are the theoretical term, but we need to understand how it is described in the Spark architecture. Okay, how it is internally used, right? What is the different transformations? So what are the transformations are there, and how to use the transformation practically? Yeah. Yes. Mm. But start first is like a Hadoop part, because Hadoop part is not too big. I'm saying this part is not too big because these are the mostly is a configuration kind of thing, except the MapReduce. So I say if someone wants to learn the Hive and the Scoop and the HBase, this is a small part. And once you do this part, then you will be free, right? Then you can concentrate more on the Spark. Okay. So our just understanding purpose, why we are learning Hadoop, because some people directly jump to the Spark without understanding Hadoop. So they face the problem in interviews or like in the work, because they don't know even the single command of Hadoop command. If I'm asking them how to copy the data from local file system to Hadoop file system, they don't know the command. It's a very simple put command is there. Okay. So I'm saying the commands is very important, because sometimes you are working in the Hadoop environment. So you should know these are the tools. Some of the tools may be not used, right? Maybe Scoop they are not using, maybe HBase they are not using, but suddenly like definitely the Hive they will be using, right? Because it's a data warehouse tool. So some of the tools you cannot deny, right? Complete Hadoop is not outdated. I'm still saying that's the reason my focus is it is just only 5 or 6 hours things, just namesake, like okay, we are aware, right? We cannot, like somebody is asking what is the name node, what is the data node, just for sake somebody is asking a question and you are able to, you are silent because you haven't learned the Hadoop architecture. Okay, so that is the reason I say Hadoop architecture or basic Hadoop fundamentals is important. We will go definitely Spark, but if we don't understand the fundamentals of Hadoop, then we will definitely lack some time. Okay, we will say like, I know very well Spark, but suppose if I say, suppose my data is in Hadoop file system and you have to read the data in Spark, right? How will you read it? What will be your answer? Because it's not a local file system. So you have to use yarn type cluster manager you have to use, right? You cannot use a local mode, right? You can't use a local mode. So Spark is flexible. Spark is not having the dependency on Hadoop. Spark is flexible. Spark can read the data from any file system. Okay, it can read from your local or it can, but Hadoop is not having that capability like MapReduce. Okay, because MapReduce is only reading the data from Hadoop file system, right? Okay, so when you are doing any data processing of any Hadoop ecosystem component, all they need the data mandatory from the Hadoop file system. Okay, if your data is not in Hadoop file system, you can't use the Scoop, you can't use the Hadoop, anything you cannot use. Okay, but for Spark is not mandatory. Spark is giving you flexibility. Suppose my data is not in Hadoop file system, I don't need to go for the yarn cluster manager. I will directly use the local mode, right? I can read the file. Okay, so that is the reason Spark is independent, right? It's not dependent on Hadoop. That's the reason you can use anywhere Spark, right? Even your local mode you can use, or you can use a yarn mode, you can use that. That depend on the use case. Okay. Okay, let's see that I will start first, just take a 10-minute break and I will start first today, Hadoop architecture and Hadoop command. Okay, and tomorrow we'll see the Hive. Okay. Okay, I will start Hadoop architecture. First thing I will cover. Okay, what are the tools? Like especially today we will take HDFS one today. Okay, and Hadoop HDFS command. Okay, like developer command. So you will get idea like what developers commands are there in Hadoop file system and how to use it. Developer command. Okay. Okay, let's connect in the 10-minute. Okay, then I will cover. Okay, so are you guys able to hear me? Okay. So I'm starting from the basics. Okay. So what is a big data all about? Okay. So what is the definition of the big data, and what other tools are there in the Hadoop ecosystem? Okay. So definition of the big data is the data is very huge amount of data, and that data cannot be handled by the traditional softwares. Like if I say like Excel sheet or like SQL databases, like where the data scalability is important. Okay. Because if you look at the last 3 to 4 year or 10 years data, the data size is growing so fast, right? It's a 10 times data is like growing, like a lot of data is coming, right? So data analytics is a big problem, right? When the data size is getting so large, and it's a data is a very large capacity of the data. So we need some tool which can handle that data, right? So that Hadoop is the one of the tool, because there are some other tools already there, right? Informatica is there, right? Some tool is there. Netija is an IBM tool, okay, and that is pretty old tool, right? Because the big data things is not just evolved from the like last 20 years, because the big data, the Hadoop came in picture in 2004 in the market, okay. But big data analytics things is a long back, right? The Netija is a very pretty old tool from the IBM, okay. But nowadays the Netija is not having the existence, right? It's not that much popular in the market now, because the first thing is Netija is not open source. It's a IBM paid tool, right? And Hadoop is open source tool. It's a open source, and you can easily set up your cluster without any like very minimal cost, right? So that's the reason like the why the Hadoop is become popular in last 20 years, right? And because it got a more popularity because it's having the large data analytics. So someone knows, right, why the Hadoop is having that capability. It can handle the large amount of data, right? If I say, if I'm a Windows machine, I have a 2 TB disk, right? Suppose I'm assuming of an example, like I have a 2 terabyte disk, and I want to process 500 GB disk data, 500 GB size of data. Is it possible to process this? Because that like Windows will not be that much sophisticated, because the block size is very small in the Windows and Ubuntu on Linux, right? Block size. What is block size? So when I say the memory, like when I talk about the storage, the the lowest term on the storage is block. So if I say I have a data of 100 MB, like I say 100 MB, 100 GB, 100 TB, like this storage is there, right? 100 MB or 100 GB, right? But this is not an understanding term for the hardware. Hardware is understanding the block. So the block definition is in the Windows, the block size is just 6 KB. Okay. And if I talk about why the Hadoop is having so large block size, Hadoop is having nowadays Hadoop 2.x or 3.x has the block size 128 MB. And this block size is also configurable. This 128 MB I can increase to 256 or 512 MB, one block. Okay. This 120 MB size is the one block. Size is one block. Okay. And same block in the Windows is just 6 KB. If I'm going to process large amount of data in Windows, it got hanged. Even Notepad will not open, right? Like more than just 434 MBs data of Notepad will not open. So can you think of, right, why? But that is designed by the Windows. We cannot say Windows is for the large amount of data analytics. Windows is just for the file system, right? So Hadoop design is such a way that it can handle the large amount of data, because less number of blocks will be there. Suppose I have a 10 TB data, and this 10 TB data I'm going to process. So how many blocks will be there? So you can comparatively, you can see it will be lesser blocks, very less blocks as compared to Windows or Unix, right? So that is the reason the design is the powerful. The design of the Hadoop file system is a powerful, that is making it the large data size like you can process, right? That. And now the question comes, how the scalability will be there? So there is a cluster in Hadoop. There is a cluster. Hadoop is not a one single machine. Hadoop is having cluster of 10 machines or 50 machine or 1,000 machine or 5,000 machine or 10,000 machine. How much capacity you want to make a cluster, you can make it. And the good part is like it is a horizontal scalability. Horizontal scalability is as many as number of machines you can add your cluster, your capacity of cluster will be multiplied. Suppose you have a 10 machine and each machine has 2 TB data. So total capacity of your cluster will become 20 TB. Okay. So till 20 TB data you can store in your cluster and distribute it. It is a distributed. So the main Hadoop concept is a distributed parallel processing. Your data can be processed parallelly, right? And all these things you are not taking care of. Who is taking care of? Like Hadoop internally taking care of. Hadoop is having the metadata. It is keeping it in the name node. So name node and data node. Okay, let me come to this. First, I will start the presentation. Okay. Okay, let's see what are the use cases. Like this is a very pretty old figures I'm talking about here. This is around 2015 slide, 9 years back slide. Okay, so can you think of this 9 years back, this slide, how much data difference will be there? It will be 10 times, right? Okay, so if I'm saying like nowadays the data size is like now Walmart is a example that time in 2015. Okay, so how can you think about it right now? The Walmart has the data that will be really huge amount of data, right? If I take it other examples like Facebook, 10 years back Facebook and now you compare Facebook, can you think of how much data will be in the Facebook? Right, millions of data is there. Okay, so they are talking about that time the data is like 500 TB, correct? Billions of users they are talking about in 2050, right? So I'm talking about the data is growing so fast, right? So data is growing fast, so we need a sophisticated system that can handle the data, that can process the data, and data should be in a cluster. Okay, and some other case, there are many use cases here. No banking or other use cases has not given, but I'm telling you this time every industry is using big data because big data is definitely needed because data engineering is a field for big data processing. Okay. Okay, so this is they're talking about the big data. So this is a huge data, like complex data, okay, and any kind of data could be a big data. Okay, so now how many types of big data? So first, three types of category at the high level. Three categories are there. Okay, either your data will lie in structured, unstructured, or otherwise it will be in the semi-structured. So structured data is a very like data is a tabular format data or row column data, or you can say fixed dimension. The data has a dimension. Suppose I say age. So age is a number field. I say date. Date is a date type of field. Okay. Or name. Name is a string field. So it has a fixed dimension. Okay. So mostly we are calling about the SQL database data is a structured data or file system data, like CSV file has the data, which is the structure. When I talk about unstructured data, there is no dimension, right? Unstructured like audio, video, images. So you cannot measure manually. If I say how many pixels there in this image, can you tell me? Can you check it the image and tell me directly, okay, these many pixels are there in this image? You cannot do, right? There is some image processing API, audio processing API, video processing API. You have to use some programming, right? Python or Java, right? You can process the image or process the audio, video. Those you can use and you can find out. Okay. So that kind of data is the unstructured data. There is no fixed dimension. There is no fixed dimension. You cannot measure the dimension with the traditional tool, right? Okay. And semi-structured data is a combination of structured and semi-structured. So like a files data is there, email attachment is there, right? Email is there. That is a semi-structured because image is there as an attachment and the body is a subject is a structured data. Okay. XML file, CSV file, those file system data is a semi-structured data because file itself is a unstructured, but contained in the file is structured. That is the reason we call CSV XML file is a semi-structured data. Okay, so these are the three categories of data. And now there are many more V's are there. This is a pretty old. There are now 5 or 6 V's are there. Okay, so these are very common V's like velocity, volume, veracity, and variety. We know like when the data is generating very huge, so definitely the velocity will be high. Suppose I say one flight is going take off for 30-minute flight. Okay. How much sensor data is generating? It is generating in half an hour 12 terabyte sensor data. Can you think of this 12 terabyte sensor data in 30-minute time? So if the flight is going from India to USA, 22 hours flight, how much data will be generated? So this sensor data is a raw data. Okay. I'm just taking an example how velocity and volume is directly proportional. Velocity will be high, your volume will be high, right? So big data characteristic is like when the data size is more or volume is more, that data is called big data. Because we cannot say the data 1 MB data is a big data. Because 1 MB data is a very small data, right? So why we will call it big data? When data is growing up to terabyte, petabyte, exabyte, gitabyte, like that data is called big data. Because the data volume is very high and data volume is depend on the velocity. Okay. And the next characteristics is the variety. When the data is coming from the different sources, like I say, the data is coming from like audio, video, picture, anywhere. The data can come from anywhere. So that data has the different varieties. So when data has a variety, that is called like it is a characteristics of the big data. And the one more characteristic is the veracity. Veracity is the characteristic is when the data is error free. Suppose I'm saying I'm giving you 10 terabyte data, but data is null data or data has some error values. The data is useful for us. The data is not useful for us because we cannot do the analytics of the data which has no value, no insights, no, the data is not correct. So data should be error free. Data should be bugless, right? Okay. Data should not have the bug. Okay. So that data characteristic is called veracity. Okay. So there are many more new characteristics. Okay. Let me show you because nowadays, how many V's are there? What are the different V of big data? Because nowadays definitely see volume, velocity, variety, 5 V's they are saying, value also they're saying. Okay, so variety, veracity, okay, oh different V's. So value they added. So there are many V's are there. Some people are saying 6 V's, 7 V's, 10 V's. Okay. So that is not a question, right? Because those are the characteristics of the big data. But I'm saying where the velocity and volume is there, definitely the data is the big data. Okay. Because velocity and volume are the directly proportional. Okay. Okay. So when I say what was the problem with the existing data warehouse solutions, so we came into the big data, right? The scaling was the big problem. We cannot scale the data because the vertical scalability was there. So we need a horizontal scalability, right? So vertical scalability was the issue in the data warehousing solution, existing data warehouse solution. So we came into the big data, right? So in the existing data warehouse solution, we had the issue of vertical scalability. The data cannot, suppose I talk about this, my machine. In this machine, how much RAM and disk will be there? It will be some disk and RAM and hard disk will be there. Can I increase the unlimited capacity of the disk? No, because there is a limitations there. Like I have some limitation of some specific limit. I cannot go more than 128 GB RAM. My system is having 64 GB RAM, but it will not allow more than 128 GB RAM because my processor, my configuration, hardware, motherboard will not allow me, right? So this is called vertical scalability. But horizontal scalability is unlimited. It's horizontally scaled, right? As many as number of machines you can add in your cluster, that is your horizontal scalability. So your SQL databases are vertical scalable. That was the problem, right? RDMS is not designed to scale out. Okay. But the new database RDMS are like new means like enhancement in your existing databases. They are providing the scalability because when they found, right, they are not able to provide the scalability solution. So now they are keep changing in their solution and design for scalability. Okay. So in that case, like NoSQL database become more popular because NoSQL is giving that capability, the scalability, right? The horizontal scalability is there, right? Mongo, Cassandra, and Elasticsearch. Okay. and the HBase, right? So these are the horizontal scalable. Okay. In the AWS, I talk about, okay. So there is a Redshift is a petabyte scale of the data. Okay. And DynamoDB is there. Okay. In Azure, there is a SQL data warehouse tool is there. Okay. In the GCP, BigQuery is there, Bigtable is there. So these are petabyte scale of the data. It can scale, right? So they have the horizontal scalability. Okay. And cost is not high because the Hadoop is providing the basically commodity hardware. So what is commodity hardware? Commodity hardware is like the cheap hardware. So Hadoop is not saying entire cluster you make a cheap hardware. So Hadoop says if you are using 10 node cluster, and this 10 node cluster, you have one name node machine and 9 data node machine. Okay. So what Hadoop is saying, keep it all these 9 data node machine, not very high configuration in terms of RAM. Okay. Or like in the configuration of the CPU, you can keep it as a cheap commodity hardware because it is providing the high reliability. High availability is providing through replication factor. Suppose one data node, you have the data and you replicate it on 3 different machine, you replicate it, right? Suppose your one data node is not available. Okay. So other 2 data node has the same data. So what Hadoop will do? So Hadoop name node will identify because it is having one heartbeat mechanism. This heartbeat mechanism, it is interacting with each data node and checking if the data node is alive or not. Okay. So this heartbeat mechanism, it will find out the one data node is not alive, the data is there. So it will assign another data node. So why Hadoop is saying the cheap hardware? The data node is fine, cheap hardware, but name node, you cannot keep the cheap hardware because name node is your gateway of your cluster. If name node is down, your entire cluster is down. You cannot access your system. It's like a master slave. So how can you reach to the slave? Without master, can you reach to the slaves? No. Master is an entry point. Okay. Suppose you want to go to the data node, you have to go through master. Okay. And master is keeping only metadata. It is not containing the actual data. But all the slaves, all your data node, like 9 data nodes, they are keeping actual data. Okay. So when I will talk about this architecture, what is a Hadoop architecture, like HDFS architecture, then I will explain about what is a name node, data node, and secondary name node. Okay. So I'm talking about here, what I was talking about. I was saying why it is like Hadoop is cost is very less because the data node can be cheap commodity hardware, but the name node machine should be high configurable. It should not be a cheap hardware because otherwise your cluster will not be available. Okay. So high configuration RAM and disk. Okay. For this particular name node should have the high configuration RAM and disk so that you can contain more and more metadata, right? Okay. Okay. So that is the reason I say, like, if you are setting up the Hadoop cluster, the cost of cluster is not too much high, right? Because the reliability is there, high availability is there, because we are not worried about our data, because we have data replication is there. So these are the all terms are coming, like scalability, reliability, like fault tolerance. You will hear this term lot, fault tolerance. So what is a fault tolerance, right? So fault tolerance means you are providing a reliability. And how you are providing a reliability? Reliability you are providing through replication factor. Your data is replicated. So by default is 3 replication factor is there. 3 replication factor. And this replication factor can change. Suppose I say my file is highly critical. I'm not believing like 3 replication factor. I say my 3 data nodes are down. How can I access my data? So I will make it for that particular file. Suppose I say this file is a highly critical file. I can make it the replication factor 5 or 7, right? It is up to you, right? How much? See, data size is not a problem, right? As much as data is like a disk is available, right? Disk is not a problem. Nowadays, 100 TBs disk or 500 TB or 1 gigabyte petabyte disk is not a problem, right? So we are not worrying about the disk size, right? So as much as disk we can occupy, but our high availability is very important. Suppose my data is not coming on the time. So if you are accessing some website and you are not getting responding, the website is not responding, you will leave it, right? You will go to the another website because the time is important, right? You are not like spending time on the opening the site, right? So the data access is the issue, not the data size, right? The data size is not a problem. Okay. Okay, so highly replication, so you can use as many as replication factor you can change. Okay, so that is a good part, right? It is configurable. As replication you can increase, okay, up to your requirement. Okay, so the cost of system is a very economic, okay, and you can store and process the data, all types of data you can process, or speed is a major factor. Okay, so the new framework came in picture is Hadoop, and it came in the 2004, right? So basically the guy dog cutting. So dog cutting is the guy who invented this Hadoop, right? By looking at his son playing with the toy elephant. So do you know, right, this elephant toy symbol came, right, because of that he saw his son playing with the toy elephant, and he gave the symbol a small toy elephant. Okay, so this is like basically came in picture, but before starting the Hadoop, already Google has published the paper in 2000, Google File System and Google MapReduce. But the Google has not put more work on that. Then this guy has take the inspiration from his paper, Google papers, and invented this Hadoop file system. And now you can see this Hadoop file system become a like a entity. Okay, so if I say now this guy is a Cloudera CEO, okay, the top leading company of the distribution of the Cloudera, right, CDP nowadays. Okay, so that is the top leading distribution of the Hadoop Cloudera. Okay, so here these are the key features already I described about this. Scalability is there, availability is there, low of cost of operation, and parallel programming model is there. So as many as number of nodes you can parallelly you can scale it out. Okay, and these are the features are there, and two core component of Hadoop is HDFS and MapReduce. Okay, let's understand what is this Hadoop core component. So Hadoop is made of two core component. One is HDFS, that is a Hadoop distributed file system, and second one is a MapReduce. Okay, so MapReduce is nowadays nobody's using. I told like it's a Java based, and we are writing a huge line of code. Suppose a one simple word count program I want to do. In MapReduce, I have to write 200 lines of Java code. Who will write this code? If I'm saying if word count I want to do with the Spark, just I can write in 2 lines, right? So if something I can do with the 2 lines, so why I should go for 200? But understanding of MapReduce concept is important. How MapReduce is work internally, that is important. It's not important how you write a Java code, okay? Because nobody will ask to write a 200 lines of code, because if the same thing is in the Spark is 2 lines of code in Spark for the same program, okay? And this program will be 100 times faster. 100 times faster also, right? So who will be using the MapReduce? But the storage part is Hadoop right there, and you want to batch processing is still the MapReduce is good, right? If you have to do some use cases, MapReduce is still good, but that is very special use cases, right? Whenever you are converting data, like some Java based framework you want to use and convert the data from one type of format, right? CSV to JSON format, or Parquet to XML format, or you can different format you can do. Okay, so when I say name node and data node, okay, so two component in HDFS. So HDFS again has a two core component. One is name node, and the second one is the data node. So name node is a master. Name node is a master node, and it contains metadata, which is data about data. Metadata means data about data node, Okay, so that metadata is stored. So how the data node data is accessible? Through master, like name node metadata. So name node has all the information about all the data node data, like which IP, which block, every information is here, is registered. Okay. So whenever you are as a client, suppose I am a client and I'm going to access my data as a file, so I will contact to this name node. So name node will be providing you the access to the data node. Okay. If any data node is down, the high availability and everything will be taken care by the name node. Okay. So once this connection is provided, then client will be directly accessing the data node. Okay. But this heartbeat mechanism is always keep going on, because name node is always trying, checking every 10 seconds whether the data nodes are down or not, and then they will assign another data node for the client. Okay. So I say master, and it is containing the metadata, and data node is containing actual data. Okay. So this, and when we will be going to process the data, so we will use a MapReduce. So MapReduce has the two core component: resource manager and node manager. So resource manager is the master. Okay. And it is allocating task to node manager. Okay. And node manager is like worker or like a slave. Okay. So one is master slave architecture is there for the name node data node, and one master slave architecture is there for resource manager and node manager. Okay. But name node is interacting always with resource manager, because who will be giving the actual task to the resource manager? Name node will tell, right? Okay, this is the request coming from the client, and provide your node manager on this data node. So name node will give information about data node used for client file, not all the data node, right? Suppose I am a client and I'm saying I have a file XYG. Okay. For the client file XYG txt, just take an example. This XYG txt file, I'm looking for the information. So name node is providing all the data nodes like this XYG txt file to the resource manager, and resource manager will identify all like whatever the data node it provided, it will activate their node manager to do the task. Okay. The resource manager will activate, or you can say enable, or you can say assign task to the node manager on data node machines. Only those data node machine, not all the data node machine. There is no point, right? Okay. So on the data node machine, the file is requested. Okay. So it will start working on all the data nodes machine, and there is a high availability things will be there if any point of time, any data node. So that architecture is there in this slides. Okay. Later I will show. And Hadoop is having the ecosystem, right? So basically on top of the Hadoop file system, there is a yarn resource manager is there, and the NoSQL database, HBase. So these are all like that time slides are there, and that time Pig was very used, right? It is a Yahoo based. So Pig is given by the Yahoo, and Hive is given by the Facebook, right? And these two are the like that time for analytics used. But Pig is nowadays is not used because it's outdated, completely gone, and it's a completely, if somebody is working in the Yahoo client, they have to still work in Pig, because they have not left this framework. They are still using Pig. Okay. So in one client, one support project, I found that the Pig they are using. Okay. So Pig is a Pig Latin script they are using. And this is operators are there, like dump operator, okay, join operator, different, it's a ETL operators are there in the Pig. Okay. But nowadays, nobody using Pig. Okay. And the ingestion data, there are two tools, Scoop and Flume. I already described that. Scoop for structured data and Flume is for unstructured and semi-structured data. Okay. Okay, so Spark, are you able to see here Spark? Right, actually 2015, the Spark, Spark is there. That time Spark is born. Okay, so Spark was a child that time. Okay, so it was growing, right? That time the Spark 1.0 version was there, very lower version of the Spark. Okay, nowadays we are talking about the Spark 2, Spark 3, right? Spark 3 we are talking about now, Spark 3.5.0. And that time the Spark was less than 1 version. Okay. So that's the reason people were just trying to start the Spark. They haven't worked much on the Spark that time. Okay. So these are the name node, and the earlier name in the before 2.x and 3.x, the resource manager is called job tracker in 1.x version of Hadoop, and 1.x version in Hadoop, the node manager is basically was the task tracker. Okay. So yarn architecture, like 2.x architecture. So 2.x architecture. So 2.x architecture, they evolved resource manager, because this job tracker had the responsibility only just like as a master. It is not allocating the resources. It is not managing the queues and those things. Okay. So nowadays this resource manager, right, is more powerful, and it is not only just allocating tasks to the node manager. It is managing the queues and all other activities doing. So now the resource manager become more responsible. Like earlier, the job tracker was just only like a specific responsibility it has. Okay. Okay. So Hadoop has a different mode are there, like standalone mode, pseudo distributed mode, and fully distributed mode. Local mode is a like development mode. I told you, right, like in a single JVM machine, like in my machine, in this local machine, I'm running Hadoop. This is single mode, standalone mode. When I'm running a machine, like one machine, but different services are there, different JVM are there. That is called pseudo distributed mode. And it is not fully distributed, or it's not standalone. It is in between the standalone and fully distributed mode. It is pseudo means it is replica of production, but not actual production. Okay. So if any issues is coming in production, it can be easily replicated here, because services are different, but in a one single machine, all the services are there. Okay. In different VMs. But here is a fully distributed mode is a exactly production, because it is separate machine, separate service, everything is separate. It's like a cluster. So this one is the highest topmost environment. Okay. Hadoop mode. Okay. So standalone is for the development purpose or testing purpose. Pseudo mode is just replica of production. Just you want to test your in a multi cluster environment, you want to multi node cluster environment, you want to test, then we go for pseudo. Okay. So pseudo is just like in a one virtual box machine, I have multiple VMs and different services I'm using, and those VMs are connecting to each other by SSH. Okay. But here is also we are connecting with SSH, but here is a one machine has a different VM, and here are all machines are separate machines are there. Okay. So I talked about the block, right? What is a block? In the Hadoop 2.x, they have given the default block size 128 MB. So if your file is a 256 MB, it will be divided into the two blocks. Okay, 128. Okay. So if sometimes question comes, okay, if my block size is just 250, so what will happen about the another block, right? Like rest of the size. So Hadoop is managing that remaining space, it will be used for the other block. So who will be managing this all block information? Name node metadata, right? So there this all information is stored. Okay. So we are not worrying about like how the data node access, how name node access. I'm not worrying about that. Okay. I'm just going to store my file. I'm going to read my file by my commands. Okay. How internally Hadoop is doing, that is Hadoop internal architecture, right? Okay. So we need to understand high level thing. What is name node? What is data node? What is secondary name node? What is resource manager? And what is the node manager? Okay. So replication factor I talked about, right? So this data is in not only just machines, data is in the rack. So rack is having the machines, and machines are in the data center. So everybody knows about the data centers, like big data centers are there. Okay. Every companies have their own data centers, right? They have large amount of data. So data is distributed in the racks. Okay. And racks having the nodes, right? So this is the rack awareness policy, how the data is replicated on the multiple machine in a multiple rack. So the best policy is one block copy on the one rack and one node, and the other two copy of the same copy of the data should be in the different rack in two adjacent node. So suppose this rack is down, you are not able to access this rack. So what will happen? It will connect you the second rack. Suppose you say second rack is accessible, but this machine is down. So you can access the adjacent node, right? So data retrieval access policy is like you can keep it one node in one rack and other two node in the other rack. But suppose you can ask one more question, right? Okay, this particular rack is down, then what will happen? So in that case, I will keep it one more application, right? I will keep it two more copies in the third rack. If this will be down, I will make it another rack. I told you, right? Replication factor is in our hand, right? We can increase as much as possible, right? I can make a replication factor up to 10 also. Okay. So that all depend on the critical, but it will be very like a different scenario. You can say ki all racks are down, right? Because it is not possible at the same time, right? Okay. Okay. So like when we are talking about, this is the heartbeat mechanism, this architecture you need to understand, like how whenever any client is interacting to the name node and how the name node is making a heartbeat mechanism and balancing and replication factor, right? So this is all the local disk, right? These are the disk on that, then data node is there, and this is the replicas. So if you can see 3 replicas copy is there, and the backup node is your secondary name node. So suppose your name node is down, so how backup node like secondary name node will act as a name node? Okay, because I told name node is single point of failure. Okay, SPOC. So SPOC, I say single point of contact, right? So if that name node is down, so how can access my cluster? So backup node will be there, secondary name node. But nowadays in 2.x and 3.x, we have standby name node concept, because this secondary name node takes 30-minute time to sync up the data, metadata. Because whenever you are saying your name node has metadata, if the same metadata is not here in the backup node, can you get the same request can be possible to serve? Your request will not be served, right? So this backup node, secondary name node, has the limitation because it takes 30-minute time delay for syncing up the metadata. So that is the reason in Hadoop 2.x and 3.x, we have like we have standby name node. Actually, this slide is old. So that time the this high availability concept and those things, like it was not that time mature. Okay. So these are the Hadoop MapReduce operations. So we will see it tomorrow. Okay. These are the installation things. All who have installation done, Yarn site, all these one. So you can know about these. Okay. So I show you one more thing is this is a MapReduce related things. I will cover theoretically. I will show the some code also. Okay. So when I come to the commands, right, I say I want to practice the command, right? I want to know first of all how many commands are there. So first thing is whenever your Hadoop is there, so you can check by Hadoop FS. So Hadoop FS is a file system, Hadoop FS, or you can use Hadoop DFS. Okay. Okay, so HDFS DFS, you can either use HDFS DFS minus ls slash, either you can use this command or you can use Hadoop FS minus ls slash. Okay, so it's just a matter of the prefix only, but both commands are fine. Okay, so when I want to check how many total commands are there to learn, just type Hadoop FS and you will see here the list of commands with the parameter. Okay. So these all commands, when you want to start the practice of the command, there is a sequence is there, right? Like, okay, you cannot jump to here, here, here. I say first you have to learn the command, how to copy the data from your local file system to Hadoop file system. And before that, how to create a directory in Hadoop file system. Okay. So suppose if I say I want to create a mkdir, what it will do? If I create mkdir, it will create a directory in my local because I'm giving mkdir only. If I see ls, I can see here the test1 directory is created, and I see ll, I can see the list in the permissions. Like I can see here it's a directory D, or if it is not a directory, it is a hyphen, and this is the user group and other permissions are there. Okay, so we know the command like chmod to give the permissions. So here I can see my test1, by default this permission is given. Okay, I got the permission this, but this directory is a local directory, but I want to create a directory in my Hadoop file system. So Hadoop fs minus mkdir, and I will create June 1st. Okay, I'm creating this. Okay, this is the directory created in Hadoop, but this directory is empty. If I see Hadoop fs minus ls June 1st. So if I check this directory will be empty. I mean, right now, nothing is there. So I have to create some file in my local file system and copy there. So I'm creating a one file, cat hello.txt. I'm writing some content and I'm doing Control D. Now this file is in my local here, right? Hello.txt. I just simply create a Linux file. And now I want to copy this file. So Hadoop fs minus put command is there. Okay, first we want to see like what is the use of this put. So just put help minus help and put like a command you put. You just say the command. Okay, then you see you will get a help about the put. What is the help about the put? It is saying the put command is copy file from local file system into fs. If you copy the file if already exists, use minus f flag. Okay, I will show that. First, I'm going to copy the file Hadoop fs minus put. What is the syntax here? Hadoop fs minus put, and then I should use any one of these options. It's not mandatory. Then provide the local source and target source, destination target. Okay, so local source is my local file system. My file is hello.txt, and the target is my June 1st. June 1st. This is my target dir of Hadoop file system. I press enter. Okay, and now I want to check my file is copied or not. I will do Hadoop fs minus ls. Then I will say slash June 1st. When I say this, I will see one of file is there. Okay, hello.txt is copied. Now I want to see the content in the Hadoop. Should I use cat command or I should use different command? Can anyone say? What should I use? I should use, if I want to see this particular file, I'm not saying the local file. I'm not saying this ls, this local file. Okay. I'm saying I want to read this file. So what command I should use?
Hadoop command.
Hadoop command. So Hadoop fs I have to use always. Okay. Then I know for checking the file, for viewing the content, there is a minus cat is there. You can find here in the syntax. Here is the C, in the C is cat. Where is cat? This one, cat. And it is saying src. So this hyphen option is not mandatory. In the square bracket, whatever you are seeing, it is optional. It is called optional. Okay. It is not mandatory, right? But sometimes you have a specific use, then you will use. Okay, so Hadoop fs minus cat, and you say, so you have to give only just hello.txt, it will find, or you have to give a complete path. What do you say? If I say hello.txt,
you give a complete path.
Because it's a virtual file system. You cannot go inside the file system, or you cannot check directly that particular file in the file system. You have to give entire path. Okay, so always we give the entire path, June 1st slash hello.txt. So hello.txt is my file, and now I can see the same content what I wrote when I created file. Okay, now if I say Hadoop fs minus put I do, what will happen? Will it copy again? What it will give? Will it copy again, or what it will say, or it will not, or it will do something else?
It's showing error.
And
Yeah.
you have to use the minus F to override it, right?
Minus F.
You have to use
Minus F. So
Yeah,
we are getting the issue here, file exists, because Hadoop is not allowing, like this is the otherwise drawback of Hadoop, right? If it is allowing, so it is a loophole, right? Suppose my file, suppose like I don't want, but by mistake I enter the command, I run it, so I will not get any confirmation and my file is overridden, right? So that is the reason Hadoop put a restriction that whenever you are trying copying the same file in the same location, it will give you error. It will not copy. Okay. But still you say, okay, I'm deliberately I want to do. So Hadoop has given the option to put minus F forcefully. Can you see here? Override destination if already file exists. Right. Okay, so now this flag is required. Now this option is required. Okay, so I told you it is not mandatory. So now it is required. Now you will not get an error. Right now you will press enter. Now it will not give any issue because you are using -f. Okay. So if you don't want to use -put command, so another command they have given copy from local. That is an alternate for that. Copy from local. But remember, the conjugative word is a camel case, right? So the first word, first letter is small, and then after each word, the letter is capital. Okay, and then you will use this. This is also doing the same thing. Okay. So copy from local meaning is copy the file from local. Obviously, you will be doing Hadoop only. Target is a Hadoop, right? Okay. So this path also you remember, if you are trying to give the local path here, like suppose some test I'm giving, and this directory is not there. So you will get the error. Suppose I'm giving test1. So test1, there is no directory is there. Will it copy? Test1 is already there. Maybe test2. Oh, copy from local is working for this. Okay, this is a forcefully I'm doing. Okay, let's try without forcefully. See, forcefully is the one big good thing is it is creating a directory also. See, if I'm trying this and I say test4. Okay, let's see this. Okay, what about the put command? So it is a very good thing, right? It is creating a directory as well, put, and I say, so what is the test5? This is also doing ls slash. So what do you mean, guys? Like it means like even your directory is not there, you don't need to create, it will be creating. But suppose if I'm trying to do test6, test7, I'm giving a big experiment. Okay, next experiment I'm trying test8. Okay, so if I'm trying this sequence I'm trying, okay, this sequence is not there. Okay, let's see, will it work this? No such file directory. Okay, so do you know, right, why it is not working?
You can use P in this.
Because it's a nested structure, right? It's a nested.
You can't create the hierarchical structure of data folder inside one folder. That's the main problem in Hadoop.
So through put command I cannot do. The result is the put command we cannot do. But if I try like this, mkdir, and I write test6, test7, test8, this is fine. This will work.
No, it is not work. It is still.
So now how to make it work?
We can use P.
-p. Okay.
Yeah.
-p.
Not
Minus P. Yeah, space will come.
Provide the
Space
space.
will come.
Provide the
Space
space.
will come. Space will come. Space will come. Okay, that is my typo. Okay, I didn't do wrong. Okay, this is created. So it means like put command can do directory only single label, right? Not multiple label, right? Okay, but in that case we have to create directory manually by using -p mkdir. Okay, so put command can do only for single directory. It can create directory even your directory is not there. Okay, if I want to check the ls/test4. Okay, let's see, it's copied file or not. Yeah, test4. Okay, so test4 what it did, you remember? Can you understand what this put it did? This put this test4, test5 we did put, right? Is it copied the file? It basically create a file with the name hello. It's not a hello. Okay, let's see the content of this file. This is a file. Test4 is not a directory. Okay, it took I'm thinking this is a directory I'm giving. This is not a directory. It took this test4 as a file, not a directory. If you see Hadoop fs -cat, I show you. I want to see the content of this test4. See, So what it did, actually, we are thinking it's creating directory. It's not creating directory. It's creating that test4/test4 is a file name itself. The test4 is a file, and this test4 file is in base directory. If you do Hadoop FS minus ls without slash, you do Hadoop FS minus ls. This is a base directory. Base directory is, okay, it is not showing here. Base directory is without slash when we give. Leave current. Actually, it is not showing here the base directory. Base directory is without slash, right? The directory. So this is the root. Okay. So these all files are there. So these are files created. If you see here, from here to here, these are all files, not a directory. Okay. So always remember, whenever you are doing without creating before directory and you are trying this operation, it will create a file, not a directory. So it will be a confusion. Okay, I'm thinking this is a creating a directory, but it is not a creating directory. It is creating a file. Okay. So if you have already directory, then it will copy the file. Okay, suppose I created a one directory, mkdir, and I say test8, some directory I created. This is a directory. Okay, and now I use the put operation. I use put, and I use, now I do test8. So will it copy, it will create a file test8, or it will create a file hello.txt in the test8? It will create a file hello.txt in the test8, because test8 is already directory. If something is already present, then it will copy the file. Otherwise, test8, it will create as a file, not a directory. Okay, so now we'll check ls slash test8. Okay, now you will see hello.txt inside there. So it's like a confusion, right? Like we are thinking it's creating directory. It's not creating directory. It's creating a file name is a slash test4. That is a file name itself. Okay. Because you can see the symbol here, right? There is no D. Okay. Okay. So this is just how to copy file, how to put a file, how to view the file. Those commands are there. And some more command is like, suppose you have a multiple file in your local system and you want to create a concatenated copy. So I have one more hello.txt is there. Hello.txt, hello1.txt I'm creating. And now I will use Hadoop FS minus append to file. Append to file, and I say hello.txt, hello1.txt, the local files I'm giving, and I'm giving a target is Hadoop file path. I say test8. That is my directory. And I want to tell what should be the name of my final file. So I say, like, I want to create a hello2.txt. Any name you can give. So now the new file is created, which has the content of both. So Hadoop fs minus cat slash test slash hello2.txt. So you will see 2 times messages test8. So if something is not found, you will get a no such file directory. Okay, how many times is there? Hello, how are you? Hello, how are you? Okay, so in the test8, how many files are there? If I check how many files are there in the test8, I have 2 files. I want these 2 files to combine and get in my local file system. What is the command? The reverse command is there, Hadoop fs minus get merge. Okay, if I want to see help, minus help, and say get merge. Command name is a get merge. Just press enter. You will get the detail of the command. So you will see get merge command is get all the file in the directory that match the source file pattern and merge and sort them into one file on your local file system. Okay. If you want to use some option like skip empty file, or suppose some file is empty there and don't want to add in your like merging, so then you can skip empty file. So if I do Hadoop fs minus get merge, and I say to Hadoop file system file, like you say test8. First one is hello.txt, hello.txt, but you have to give the complete path because it's a Hadoop path. Test8 / hello2.txt. And now you need a local file, just you give any name. Suppose I say hello3.txt. So here I don't need to give the complete path because I want in the same directory. I say hello.txt. Okay, now I say cat local file. I can see cat hello3.txt. Can you see 3 lines are there? It means one file is having 1 line and one file is having 2 lines. The total 3 lines are coming, right? Okay, so this is the like a merging of the content of 2 files, not only 2. You can give n number of files in the this append to file. You can give hello1.txt, hello1.txt, hello1.txt. But last one should be your hello. I make it 4. It should work. It work, right? Now you see Hadoop FS minus cat test8 hello 4.txt 4.txt. So this all will come with the practice. See how many times I put it hello, 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 1 hello, 1 hello, 1 hello, 1 hello, 5 hello. How many hello is there? 5. Okay. Okay, so this is a command for the, so there are many more commands are there, like had command is there. Suppose you want to see the content of the file. So these are all Linux command only, MB command, copy, and okay, CP or MB 2 commands are there, but CP or MB command is used in Hadoop file system for copying the file from the Hadoop to Hadoop. Abhi so far you are copying file from local to Hadoop or Hadoop to local. Okay, but now if you want to copy the file from one directory to another directory, so you can do Hadoop fs minus cp and you say, okay, suppose I want to copy this test8 / hello 4.txt to /test1. So this is copy from Hadoop to Hadoop. So already file exists, right? So hello 4 is already there. So if I want to do forcefully, what I should do? Put -f. Okay, so here -f will work. So CP means copy both the side, same copy there. Okay, but if I want to use MB command is a cut paste, right? Suppose you want to move a file from there, so then you can use MB command. Okay, so your file is moved from the there to there. So Hadoop fs minus, but can you try with -MB with F command? It will not work. Okay, because MB is not applicable, like -F is not applicable for F. So -MB I try, I say test8 and I say I want to move hello4.txt, but already my test1 is there. I cannot do. So what I will do, I will give some different name. I say hello5. Okay. So the file will be moved with the name hello4 to hello5. Okay. Test1 is not a directory. Okay, we try test8. Okay, just I gave, we have many directory, like we have test directory is there. Okay, so we try test. Okay, it is moved up. Can I see there the file is present? ls test8 / hello 4.txt. I will not get my file because the file is moved. No such file directory. Can I try again this -f again? What will happen? Because file is not exist, right? Okay. So the file is already exist. It's saying file is already exist. If I try -f, what it says now? So -f option is not allowed for MB command. If you see MB command here, cp MB. So there is, if you check the help, so if you do Hadoop FS minus help and say MB, so you will come to know there is no option is there after minus MB. If you want to see the uses, one command is also uses. So uses and this help, what is the difference? Help is giving the detail, but uses is giving only the parameter. Like what are the options are there? So it shows only the options like this. So this is the part, right? This one is here. Okay, so uses command, you can see only options things. And if you want to see the detail, you can use help command. So there is no option is provided to the MB. Okay, so whatever is provided here, that only you can do. Otherwise you cannot do. Okay. Okay, let's do this history I will give you. You can practice this. Okay. So this is all command we try. So you can same thing like you can create a command, all those things. Okay. So I think here it will not go to the history. Okay, I will prepare a document. I'll send it with this document. I will add in the class. I will provide this one. Okay. Anyone has any questions? Let me know. Okay, let's connect. So I will complete the Hadoop command and then MapReduce concept, and Hive will start. Okay.
Thank you.